100 years from now, the world is gonna freeze. This is what will happen. Everything is frozen.
Alright, so this is the physics behind the block frozen in time. So since we know the block is not changing its velocity in any way, its acceleration is zero, we know that the net force of the system is going to be zero. So let's break these components up into forces that are parallel to the ramp and forces that are perpendicular to the ramp. So let's first look at the forces perpendicular to the ramp. We have the forces in the normal force, and then the gravitational force counteracting the normal force. We know since the system is zero, that the normal force has to equal to the gravitational force in the perpendicular direction. So if we were to plug in the expression for the gravitational force in the perpendicular direction, we have mg cosine theta. M in this case is going to be 0.174 kilograms. Gravity is going to be 9.81 meters per second squared. And cosine, cosine of the angle, which would be 21.19 degrees. And when we do the math out, we get that the tension in the that the force of gravity in perpendicular direction has to equal to 1.589 newtons. If we do the same for the forces in the parallel direction, we have the force of static friction minus the force of gravity in a parallel direction, and that equals zero too, since it's not moving. So the force of static friction equals the force of gravity in parallel direction. Force of static friction would have to force of gravity in the parallel direction would be mg sine theta, and that's what the force of static friction equals to. And this would come out to be 0.6226 newtons, which is basically the mass times 9.81 meters per second force of gravity times the sine of our angle. So actually, Hunter lied to you, and in 100 years from now, the world does not freeze, but this simple trick was demonstrated through some simple physics, and these are the equations that show the weight, the masses that counteracted the weight of the block. The mass used to counteract the weight in the parallel direction would be 0.063 kilograms, or the mass of the block times sine theta, which in our case is 0.174 kilograms and sine of 21.9 degrees. And then the weight, the mass in the perpendicular direction would be the mass times cosine theta, and in this case would be 0.162 kilograms.